take a look at actually doing some combinations versus some permutations in your calculator. So the first one that we want to do, and we'll do them also by hand, is the 11C3. And using your calculator, you'd have to make sure that you type in your 11. So you'd have to type 11 in. Then you'd have to press your PRB button. PRB is short for probability. Select the NCR. Press enter. And then you could, once you get back to the main screen, you could press your 3, type in 3. And then press enter one last time, and you'll get the actual value for the 11C3, and it will look something like the following, where you get the final answer displayed on your calculator of 165. Now, we do also want to do this by hand just to make sure that you're comfortable with this. Remember, to do this by hand, we need the formula. And again, the formula will not be given to you. This is going to be if this is something you want to do by hand, you need to memorize it. It's NCR is equal to n factorial over, and it's going to look just like the permutations, at least to start, n minus r factorial. So far it just looks just like a permutation, except for we're going to add just this extra piece of r factorial in there. Other than that, everything is exactly the same as permutations. So we'd start out with Rn, which in this example was 11. So we'll start out with, on top, we'll start out with our 11 factorial. And then we have our 11 minus R on the denominator that's going to come first. And the R here is our 3 in this example. And then times our 1 extra factorial is our 3 factorial. So let's write out and translate what everything means first. So on top, we've got, let's see, doing this by hand, we've got our 11 factorial on top, which is 11 times 10 times 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1 on top. And on the bottom, notice what we actually have is inside of our parentheses, we've got 11 minus 3 factorial, which is, if we were to simplify this guy, would be 11 minus 3 is 8 factorial. So that would be 8 times 7 times 6 times 5 times 4 times 4 times 3 times 2 times 1. And then we have our 3 factorial right next to it, which would be 3 times 2 times 1. Now what we can cancel out is, notice, from the 8 factorial on the bottom goes 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. We have that same piece up top from our 11 factorial. So every piece that's the same on the top and the bottom can get canceled out here. That will make our life a whole lot easier. And remember, again, just like before, the ones on the denominator or on the numerator, multiplying or dividing by 1 doesn't matter, so we'll cancel that out. So now we just got the 11, 10, and 9 on top, and the 3 times 2 on the bottom. We can reduce this a little bit more. So let's take a look. Let's see, we've got a 3 and a 9, which are both divisible by 3. So 3 can go into 9 3 times. And let's see, we've got also a 2 on the denominator. 2 can go into 10. So 2 will go into 10 5 times, and we're all done reducing. Now we just need to see what's left over. So the question is, what do we have left over? Well, notice that we have left over, we have an 11, a 5, and a 3 on the numerator, so it'd be 11 times 5 times 3. Everything on the denominator has canceled out, so there's just the hidden 1, which means you don't need to write that. So really all we're looking at is the 11 times 5 times 3, which gives us the same total before as we were doing this in our calculator, which is the 165. So it's really up to you. It can't hurt to understand how the combinations work either. So let's do another one using the permutations in the calculator just as a reminder how that works. So let's try the next one, which is basically the same numbers, the 11 and the 3, but this time with the P instead of the C, the permutation instead of the combination. So the permutation would work the same way as the combination in the calculator. You'd start by typing your 11, then pressing your PRB to get your P, and then typing in your 3 and pressing enter, and it would look like the following when all was said and done and you'd get a total of 990. And notice that's quite a bit bigger, and that's because order does matter with these, so swapping things around would change your situation and would be counted as a different unique possibility. Now to show you how this would work by hand again as a reminder, we need the formula, which looks very close to the combinations, just a little bit easier actually. It's NPR is equal to the n factorial over the n minus r factorial. So the only difference between the combinations and the permutations, again, as a reminder, is that you don't have that extra r factorial with the permutations. So our n is our 11 that we would fill in first, and then our 3 is our r that we would fill in second, which gives us, let's see, on top, an 11 factorial, just like before, and on the bottom, let's see, we'd have an 11 minus 3 factorial, which we did do something just like this in the combinations, and we had to deal with the 11 minus 3 first, which actually gave us a total of 8 factorial on the denominator, because you had to do what was inside the parentheses first, and left our 11 factorial alone on the top. And then we can translate what we have. So let's translate what we have here, and let's start with the on top part, which would be the 11 factorial, which will be 11 times 10 times 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. And on the bottom, we've got our 8 factorial, which is 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. And notice that there is a lot of stuff that's in common that we can cancel out from the top and the bottom, which is basically the 8 all the way down to the 1 on top that is the same on the bottom because of the 8 factorial. So all of that can cancel out. The 8s, the 7s, the 6s, the 5s, the 4s, the 3s, the 2s, and the 1s, which just leaves us with 11 times 10 times 9. So the question is, what does that end up being? Well, the 11 times the 10 times the 9 does give us the 990 that we got before. And notice that is the same answer that we get using our calculator. In this next example, we've got